In trapezoid ABCD, angles B and C measure 60 degrees and AB equals DC. The side lengths are all positive integers and the perimeter of ABCD is 30 units. How many non-congruent trapezoids satisfy all of these conditions? So let's make some variables for some of the side lengths. Let's suppose that AB is x. This would mean that DC is also x. And let's also assume that the length of AD is y. So x and y are both integers, positive integers. Now, what is the length of BC? We could make another variable z, but it turns out that we can find BC in terms of x and y. The way to do this is to draw this line here from D to make an equilateral triangle. So I'm drawing this line so that it's parallel to AB. And this is going to imply that if, let's say, E is the point where DE is parallel to AB, this is going to imply that angle DEC is 60. Therefore, EDC is also 60. And triangle DEC is equilateral. This means that EC will be x, BE will be y, and therefore BC is equal to x plus y. So therefore we can now find the perimeter in terms of x and y. We're given that the perimeter is 30. And in terms of x and y, we see that the perimeter is 3x plus 2y. So this is the main equation that x and y need to satisfy. And remember that x and y are integers and they're both positive. So all we need to do is find the number of ordered pairs of positive integers x and y such that 3x plus 2y is 30. And we can quickly list them out to see that 8, 3 is a solution. 6, 6, 4, 9. Lastly, 2, 12. So it's worth mentioning that all 4 of these solutions do satisfy the triangle inequality, or in this case, the quadrilateral inequality, because we also need to make sure that any 3 sides sum to a number that's greater than the 4th side. But that will always be the case for this problem. So we have 4 different solutions, x and y, and they're going to give 4 different trapezoids that are not congruent to each other. So we can conclude that the number of trapezoids is 4, or choice E.